So this is my PCB design, which I've done in Eagle. If you go to view and layer settings, I mean, I'm quite new to Eagle, so I'm only just figuring this out really, but yeah, these, you can turn various ones of these off, so that what you're left with is only what you actually want to print and what you actually want to etch on the board. I don't know what most of these mean, but basically just, I think how I did it was turned off everything except for these top few, and then gradually started turning things back on and fiddling around until I was left with that. Then we'll go to print, and if we choose black and solid on there, then it should just print in black the parts that we want etched. I have got some of this heat transfer sheets, which I've found on eBay. There's hundreds of different ones available. I can't tell you which ones are good or bad because these are the only ones that I've ever bought. Now, with my particular laser printer, which is brand new, is the Brother HL3170 CDW. This particular printer, I had some problems printing off these transfer sheets. That was the result. Basically, it won't go into too much detail here, but if you look at the fuses on the back, I'm not supposed to touch these, but up above the red one behind, there is another fuser, and for some reason, whenever I print on the yellow paper ends up wrapping completely around that fuser. I managed to get it out. It doesn't seem to have done any lasting damage, but it can't possibly be good for the printer. So, thanks to another absolute genius post that I found this idea. You take a regular sheet of paper and then tape a small piece of the laser transfer onto it, then it will go through. And there we go. So now, because I've already told it to print, my printer is politely waiting for me to put a piece of paper in, and that will wake up. I've opened the back of the printer as well so that it'll come straight out rather than having to roll all the way around the rollers. And there it goes. Look at that. Isn't that beautiful? Now I am going to peel this off and then attach it to my circuit board toner transferring machine. Okay, so here we are at the other end. I've got my PCB, I've got my printout. Now, again, just based on what I've read that you can get a bit of oxidized copper on the outside of the board if it's been resting for a while. So, not a bad idea, just a bit of wire wool. Just maybe take the tiniest little layer off there. And then, to make sure that there's no grease or anything like that on there that will get in between the toner and the board, a drop of acetone, and then hopefully that will leave the board all nice and shiny. Little imperfection in the corner, I don't know where that came from. This isn't the first time I've attempted this on this particular board. This has been a transferred toner onto this before, so yeah, obviously I haven't etched anything off it, but I've tried various different methods before I figured out that thing with the taping a piece of paper. I even tried using magazine paper and stuff like that, so yeah, hopefully this will be the last time I transfer anything to this board, because I'm hoping that I'll be able to etch it after this. So, I've seen various things written about what temperature to use for this. I don't have a way of changing the temperature of my iron. Well, obviously I do. I've got the settings for cotton, linen, whatnot, but I don't have a way of telling what temperature it's at. So, as this is an experiment anyway, we'll never know if we've got it right until we do it. So I'm just putting it on what is my iron's maximum temperature setting. Ah, now I've just touched the copper part of the board, so just in case, I'll do that again. I don't know how sensitive this process is to finger grease. It'd be very annoying to lose the board to that at this point and have to do the whole thing yet again. So the process here is we put this ink side down onto the copper side of the board, and then we take the iron, put the iron on the top, and then that will melt the toner onto the board. So again, what I've read is pressure is important. You need to apply lots of pressure in order to get it to stick, and there's a bit of a trick for how to do that, which I'll show you in a second. So first thing we have to do is we have to try and line that up with the board. Now, I have screwed this up in the past, so you can sort of see through it a little bit. I'm sure there's a better method of doing this using a light box or something like that, but all I'm going to do is just try and use my eyes and get that set as close as possible to the right spot on the board. And then what we can do, actually you can see down here I've got an area of the board that doesn't have any toner on it, so I'm going to use that to kind of pin it down in place, and then I don't need to worry about using the heat on that part because there isn't anything to transfer. So with that in place, when we put the iron on, because of the glossy side of the board, it should stick the paper down to the board within a few seconds. At least that's what I'm hoping. And so then that means that we don't need to worry too much about moving the paper around on the board. So let's give this a try. And that goes. Press nice and hard. Give it about maybe 15-20 seconds, and then that should stick the paper to the board, he says, hopefully. Okay, that should hopefully be stuck pretty firmly now. Now, one thing I'm not sure about is whether my iron is a constant temperature across the bottom of the iron. Again, it'd be nice to have one of those little infrared temperature sensors, but I don't have one. If you do, why not check the temperature at the different points on the base of your iron, and then we'll be able to see if it's a constant temperature or if we do need to in fact worry about moving the iron around. I have read as well that using a cheap laminator to do this works very, very well. So again, if you've got one or got access to one, if this turns out not to work very well, I might have a look for one on eBay, see if I can find a cheap old laminator. Apparently there is a bit of a project that people do where you modify a laser printer so that instead of printing the toner on paper, it prints the toner onto a circuit board. But looks like it's quite a beefy old job, and obviously it destroys the laser printer in the process. So since my laser printer is less than 24 hours old, I don't really feel like taking it apart just yet. Right, that should be stuck down pretty firmly. Now the next trick that I've looked at is to use a, well, on the page I read it was a piece of dowel, but in my case it's a pen, basically as a way of getting pressure all over the surface. So what's happened here is because of the way that the paper melts, it's actually stuck the paper down a little bit to the cardboard as well. So peel that off. Oh. There you go, at least we know it works. So here, I'll take a pen and place that on top of the board, sorry, underneath the board, and then the idea is then, if we put the iron on and roll it over the pen, then it will put more pressure on specific areas of the board. What would be a great thing to do here, and which I might do one day, is to actually try all these different stages on their own. So try not doing the thing with the pen and see if that makes any difference to the end result. But at the moment I've only got so much toner transfer paper, and I don't really want to do 100 different experiments and use it all up, at least until I've bought some more. And at the same time, I don't really want to buy any more transfer paper until I know that this process works. Right, one more great big press for luck. That's while I'm here, you can see this is what's left on the paper from the previous attempt. You can see the bits at the edge, the larger blocks, have not transferred properly. The reason for that is partly because I put the paper down in the wrong place. You can see it overlapped the board a bit wrongly here, which is why I've abandoned this one. Also, I think it might be because of the trick with the pen, it's hard to get the pressure right to the very edges of the board. So I'm just going to cover that edge of the board and just really put some weight on that, just to make sure. Might also be because that's a larger block of toner, I don't know. Might be that needs more temperature or pressure or time to transfer correctly. Okay, right. Now, of course, the board underneath all of this, the paper's not so bad because it's paper, but the board underneath is incredibly hot. So just be careful about touching it. What I'm going to do now is, there we go. So now if I put that in there, firstly it will cool it down so I don't burn myself on it. Secondly, if the paper absorbs the water, then it should make it easier to peel the paper off the board. Okay. And let's see what we are left with. Now I'm going to peel the paper back off the board. Now, look at that. I don't think that is entirely bad. You see there's still a few little imperfections. Again, note they're at the edge of the board, so I'm imagining that's because I've not been able to put enough pressure at the edge. Maybe that extra big push that I did on these blocks at that side, I should have done at that side as well. So, right. The next thing to do then, I have read some people now get another piece of transfer paper, put that on and do it again. I've tried that in the past and it didn't work terribly well for me. Firstly, obviously even if you're a fraction of a millimetre out with the position, then it really shows, especially if you've got some fairly small tracks, although I suppose these aren't small tracks in the PCB world, they're huge. But yeah, if you're a tiny little bit out with the position, then you end up with like a sort of like a double exposure effect. And secondly, I didn't find that it really added anything. It didn't really add any more toner to the board. So the next thing that I'm going to do is I'm going to dry this board out a little bit, and then I'm going to try and touch it up with a Sharpie. Okay, so this is the board when it's just finished with the iron. So this is just where the toner is. And I'm now just going to touch up a few of these little imperfections here with a Sharpie pen, which I have actually used to make boards before, not entirely successfully. So, as fascinating as it would be for you to watch me do this, I am not going to let you, because I don't have a tripod to hold the camera, and it wouldn't be particularly interesting anyway. I'm sure you know how a Sharpie pen works. So this is before, and here is after. So, hopefully you can see where I've improved things. I wish I'd paid better attention when I was colouring as a child, because I'm not very good at keeping inside the lines. It was very tempting to attempt to go over the whole thing with Sharpie, just to make sure that you know, it's got the best level of cover. But then I thought, well, then that doesn't show me anything. I don't know then if the toner transfer actually works reliably, or if the toner transfer isn't doing anything, and it's just a template for the Sharpie. So there are still a few slightly weaker areas. If you look at this track here, for example, is it's all covered, but it's not sort of thick, solid black. So it'd be interesting to see if that lasts once we put it into the etch, which I'm going to do now. So I have constructed an etching tank. What that means is I've taken a nice cream tub and filled it with etchant, but I have attached to the side this motor with a cog with a lump of blue tack on it, and what that will do is vibrate. It's the same sort of mechanisms as in a vibrating mobile phone or a video game controller or something. It's just a lopsided weight on the end of a motor, which makes it wobble as it spins. So I've attached that to the side of the etchant tank because you're supposed to agitate the tank continually while it's etching off the copper. I've just wired that up to my power supply so that I can control the voltage and turn it up and down. And if I turn that on, you will see that there's a bit of a ripple in the etchant, because and you can feel that vibrating quite a lot because of the motor going round. So, bit of an experiment. I've just built it right now, so we'll see what happens, and maybe I'll end up with etchant all over my office. Speaking of etchant, this is the stuff I'm using. Ferric chloride, a horrifically horrible, evil substance that you should never go near. It will stain anything it touches in a horrifically permanent way. So just be very careful with it. Apparently it also releases some unpleasant gases, I think, while it's in use. There's warning labels on the back that it's corrosive. Well, obviously it's corrosive because we want it to dissolve copper, don't we? So yeah, just worth being very careful with this stuff, I think it's safe to say. There are alternatives to this. I've just actually today just read about mixture, something you can mix yourself. Now, what is it? Hydrogen peroxide and hydrochloric acid or something like that. Anyway, if you have a look on the internet, you'll find apparently it's quite easy to make. It's clear, so it doesn't stain. It's incredibly cheap, and a lot of people are saying it's much better than the traditional ferric chloride. So remains to be seen, that one. So here's my marked up board, and there's my etching tank. Oh, last thing to say, sorry, I did just warm the etchant up ever so slightly, just because I think that makes things happen a little bit quicker. So it's just barely above room temperature at the moment, but I thought that might help, you never know. So on my to-do list one of these days is to build myself a reflow solder oven, and if I ever do that, then I might be able to repurpose it as a low temperature heater for etching circuit boards, but yeah, we'll see what happens there. So, moment of truth. In goes the circuit boards. But rather not get that all over my fingers. So, in fact, I'll tell you what, I'll use the eraser end and then I can show you what I mean. Then it goes. That orange there that's on that eraser, if I rinse it off right away, it'll probably go, but I'm going to leave that on there and see let's see what it looks like when it dries up. But it's pretty permanent. If you get it on any clothes or anything like that, then forget about it. So the board is in the etchant. Let's fire up the agitator motor. And there we go. Right, so the time right now is 12:37. We'll give that 10 minutes and then I'll have another look. Okay, here we are 10 minutes later. And if we pull that out and just let it drain off a little bit, yeah, we can still see that there's still quite a lot of copper. You can see as well that it doesn't seem to be etching off. You can see it doesn't seem to be etching off entirely consistently. No, I would have thought, for example, that the smaller bits in between those little black traces on the bottom would etch last, although I don't know why. I don't know what I'm basing that on. Okay, I'm going to give it a stir around and then maybe give it a few more minutes. As you can see, I'm reusing the pencil that I used to stain the rubber with the ferric chloride, so okay, I think we're getting there here. Sorry, my camera control's not very good when I'm looking down into the action. And that seems to have gone. Right. I am going to go and get some gloves so that I can take this out and give it a rinse off. Okay. Okay, here we have the board removed from the etchant. It's not completely clear whether all of it has come off or not. Also worth saying, it's important that you don't pour the etchant down the sink. I don't know what the rules are regarding rinsing a little bit off like this, but I'm going to go ahead and assume that that's going to be harmless. But yeah, don't go pouring a litre of it down the sink, because it will do a lot of damage to the water system and the environment and everything else. Similarly, it might do damage to your sink, so if you do spill any of it in the sink, or even just rinse bits off like this, make sure you scrub it all nice and clean afterwards. Right, let's knock that tap off. I think we're looking pretty good here. Let's get set up and give it a good clean, and we'll see what we're left with underneath. Okay, we're back here again. So, now, also I've just come back to this section to discover that I actually left the iron on when I was here before, so don't do that. Right, the next step then is to remove the etch mask from the board, which again we can do with a bit of acetone, and then this is the moment of truth, which should tell us how well this little experiment has worked. Oh, that doesn't come off as easily as I'd hoped. There we go. This is looking pretty good, I think. Right, one lesson learned. You can't really see a direct comparison here because I didn't show you the old way that I did it, but I really recommend that agitation thing, that little motor that I put on the etching tank. That made all the difference, because I've done this before, as I said, with the Sharpie method, and really didn't get nearly as good a result as this. I found that because I had to leave it in the etchant for such a long time to start getting off all the little bits in between traces, like up here. So because of that, after that length of time, it starts eating through the Sharpie and might start eating through the toner. I don't know. Hopefully, I'm never going to find out. So yeah, that agitation, that's really made a difference. Okay, I hope that is pretty clear. I think that's gone pretty damn well. All of these up here are just nice and shiny. Don't know what that is on there. See if I can get rid of that. I don't know. I'll be drilling that anyway. But yeah, you can see up here, this is the one where the toner mask was a bit weak, and you can see it's not affected it at all. The only little imperfections, in fact, are down here, which is where I topped it off with a Sharpie, so you don't have the nice straight lines because I did that with the Sharpie, which actually was probably mostly unnecessary from the look of things. So yeah, I'm pretty happy with that. Next thing is to get it drilled and actually wire it up. I mean, I suppose normally what you would do at this stage is get a multimeter on it and actually test your different tracks and whatnot, especially if you've got very narrow ones. And because I've got such big tracks, it's quite clear to see that there's not going to be any short circuits or any connections. I'll check it anyway, I suppose, but yeah, onwards and upwards. Maybe we can try doing some much finer tracks next time.